Okay, good afternoon everyone, and welcome to this last session of this two-day symposium. Lily set the bar very high, so I just hope that I'm not going to make you disappointed. So that's actually the title of this presentation today, but we'll see that it's basically kind of introduction to our activity-based model and its applications and the possible modules that are available to be used. The first technical, oh yes, okay. So first, locating ourselves. This is actually the map of Europe, and we are in this tiny little country in the northern west part of Europe called Belgium. Later on I will come to that issue of Belgium, Flanders. There are lots of complexity and lots of issues that also affect the sort and the kind of research that we actually carry out. So locating our Institute for Mobility, or IMOB, in a Belgian context, that's the first thing that you can see, that all these universities are actually located in Flanders, the Dutch-speaking northern part of Belgium. And the reason is that, unfortunately, just like political divisions and distinctions that they made, so the Dutch-speaking part versus the French-speaking part, there are also not much collaboration and possibilities to deal with and to collaborate with the universities in the southern part of the country. And that's why we basically collaborate with other Dutch-speaking university partners, including University of Ghent, Antwerp, Free University of Brussels, Catholic University of Leuven, and U Hasselt. So where we are actually located, I personally am belonging to the Faculty of Engineering Technology of Hasselt University, which is actually a collaboration between our university and KU Leuven. But the Transportation Research Institute, IMOB, is basically, it belongs to the School of Transportation, and it is one of the 5 research institutes that belong to Hasselt University. We are actually busy with 5 different core fields of research: transportation management, traffic safety, logistics, ITS and behavior, and also tourism. Why sustainable or smart transportation? Actually, that's the kind of question that we often ask ourselves, and today I hope to just demonstrate one possible answer to this very commonly asked question. So we basically, as ordinary people, we do activities every day. So different types of activities, including sleeping. We actually spend 1/3 of our lives sleeping. We commute to work. We work. But besides these main activities, we also have some recreational activities, including sport, shopping, mainly for ladies, and partying or some sort of leisure activities. So, as you can see, there are different types of activities that we do all around the clock, and we do need to do that in a more sustainable and a more smart way. But how we can do that? We basically make trips in order to make those activities and to go from location B to location A, or vice versa. And how we actually do that, there are different transport modes at our disposal. Slow mode or active mode, because some people, slow mode does have a kind of negative sort of effect on people, so they don't like slow mode. That's why many people call it active transport mode. So including walking or cycling. But there are also some motorized transport modes, including public transportation, buses or trains, and also private cars. We also do these trips all over the place, so from every possible origin to every possible destination. And we also do that at different times of the day, so early in the morning, in the afternoon, late in the evening. One possible question that comes into your mind is that basically what could be the impact on road network in case of specific changes that we basically foresee. These different changes can be related to infrastructure. They can be different travel demand management strategies that are going to be implemented. So what are the impacts, or what are the consequences of certain choices or certain strategies that we actually follow? So road construction is one of the major issues that different policymakers and also road authorities are busy with in order to see what kind of impact does it have during the construction and also even after the new infrastructure is open to the public. For instance, increasing parking ticket prices. So how increasing public parking ticket price could potentially influence people's behavior? What kind of impact do we expect? Basically, we see, or we could imagine that by increasing public or private parking ticket prices, people tend to use less private cars because parking could be an issue. Or on the other hand, they could say that, okay, now that the tickets are more expensive, so there are less demand, so it means that I can take my car and then I have the opportunity to actually park my car in the parking. So each and every of those scenarios can have positive or negative impacts at the both sides of the spectrum. Building a new shopping center. So what kind of activities does it actually initiate or triggers? What kind of infrastructure do we need to accommodate all those new trips to that location? Decreasing bus ticket prices. If we decrease bus ticket prices, are we going to make it more attractive for people to just use more public transportation? Or some people may say that, okay, now that it's cheaper, there will be lots of people, so the comfort level will go down, so I'm not going to take bus anymore. Aging of population is also another question. I'm not sure how the situation is here in Brazil, but in Belgium we are actually facing this phenomena that is that our society is becoming grayer. Means that there will be more and more people who are on pension, and the reason why is it important? We need to accommodate those elderly people's mobility and autonomy. Where do those elderly people tend to live? Because in the specific case of Belgium, at the coast, people tend to go to the coast and to live there. So as transportation planners or road authorities, it's very important to know what kind of impact could aging of population, for instance, have on our transportation system and our people's behavior when it comes to use different types of transport modes. So these are all different questions that are kind of related to the general question that we have, okay, what should we do in case of any changes, and how we can actually do that in a more sustainable or wise way. Here, I mean, from now on, I'm going to just demonstrate our activity-based model, which is a potential answer to this very specific question. Our activity-based model is called FEATHERS, the Smart Activity and Travel Predictor. It's actually a son or daughter of albatross. I don't know if you have heard of that system being developed by Theo Arends and Harry Timmermans from TU Delft in the Netherlands. This platform has been implemented not in Belgium. This is the map of Belgium, because it's not advised to use the map of Flanders only and put the map, because I mean the flag, because it's a very tricky issue. I don't know if you are aware of all those tensions and intentions to be more independent, especially the Dutch-speaking part or Flanders. So it has some consequences on our own and on researchers and how we get access to data. But here I couldn't just put Flanders map and flag. So I put the Belgian flag and the Belgian map, but we mean Flanders. So feathers has been tested in Flanders, in Seoul Metropolitan in South Korea, in Slovenia, and in a very small council called East Hampshire District Council, which is near Portsmouth, between London and Southampton. So, what is basically feathers? Feathers stands for forecasting evolutionary activity travel of households and their environmental repercussions. So, this is basically a tool that allows us to predict trips for each and individual member of the studied area. And we can also predict their activities all around the clock, what kind of travel behavior we do expect from those people and from those individuals. And it is possible to incorporate different types of scenarios and test what could be the potential impact on our transportation system. So what can we actually do, or what can we compute using feathers? There are different possible scenarios, but not limited to what I am just going to demonstrate to you. Growing up population is one of the things that we already discussed about it, so that's one possible scenario. General increase in income, because you know that if you increase the income of people, normally the household income, if it increases, people tend to buy more private cars, which means that they are inclined to use their private cars even more. So it has certain consequences on our transportation as a whole. Increasing fuel cost. So if we just increase the fuel cost, how people are going to react on that? Will there be a kind of shift from car usage to other modes of transport? Will this be a kind of permanent modal shift, or it will just disappear after an amount of time? Changing opening hours of different activity locations. So one of the maybe interesting things is that in Flanders, what we do actually, or what the government has done already, they try to spread out the opening hours of different activities. So the earliest ones are actually schools. So they start at 8:30. Then different shops are opening from 9 until 10. Some banks are now opening at 10 o'clock. Other banks are opening at 9 o'clock. So how our transportation demand and how our individual behavior would be in case of changing the opening hours of different activities? Are they going to accommodate themselves, or do they find it difficult, so they change their decisions? So, okay, today I'm going to go to school, get the kids to school, and then I have to go to work. The bank opens at 10 o'clock. It used to be opening at 9, but now it's at 10, so I'm not going to go to my bank, so I'm doing it on another day. So all these things, although they are at a very individual scale and a very low scale, but they could have significant amount of influence and impact on the total transportation network performance. New facilities and relocation. So if you're gonna open a new mall, a big mall somewhere, so it attracts basically lots of trips, but how to accommodate those extra new trips? And if you want to just relocate one point of interest, what could be the different impacts on our individual behaviors? Changes in transportation network, so adding extra lanes, changing the infrastructure, changing the control type of our transportation network. These are all different possibilities that may have an influence on people's behavior. Also changes in public transport network, either it's going to be a cheaper ticket or a better and more comfortable bus, which is having an airco, or if it's going to be more regular sort of trip schedule, so that people are more inclined to use public transportation. Also, construction or reconstruction of roads, what could be the impact of these on those different places? So how feathers actually work? We basically start with a series of input data, and then we predict travel behavior of individuals. Then we get some sort of output material, including activity travel diaries of different individuals in the entire study area, like in the case of Flanders, for almost 6 million, 6.5 million individuals. We have all the daily diaries from 12 o'clock in the midnight until the next day for each day of the week. And for different trip purposes, different transportation modes. And then what we can do actually with that kind of output, we can have activity and travel statistics, which are relevant for policymakers. Later on you will see some examples. There are also possibilities of assigning that traffic to our road network to see where are the bottlenecks and where can authorities actually intervene and change something so that the situation gets better. Also, we can use that kind of output that we get here as an input for some specialized models. Those are like emission models, traffic safety models, electric vehicle models, and different types of models that are going to be discussed a little bit later. So what I'm going to actually tell you in the next slides, I'm going to describe each and every step with some examples, some tangible examples, so you can understand or better understand how policymakers can actually use such a model in order to help them create a more sustainable transportation network in a more clever way. So a little bit about the input data. The input data, first thing, is actually the study area data. So where we are gonna basically predict our transportation network and the individual's behavior. So there are different zoning systems. In our case, we actually defined super zones, zones, and subzones. Just to give you an idea, the entire Flanders is divided into 250 super zones and 2,300 almost subzones. And the area of each subzone is somewhere around 5 to 6 square kilometers. So that's just to give you an idea how big or how small each of those geographical entities look like. Then we also need to have the transportation network. That's inevitable. You need to have that information in order to see how people would basically behave. In this specific case, we also need to have public transportation. there are different aspects that we need to get some information from. Cost, travel time, number of bus stops, number of train stops, their schedule, how they are comfortable, are they equipped with, let's say, those panels that give you some sort of information about the arriving stops or the travel time to your final destination or not. So these are all information that we need to get for public transportation. Number of parking spaces available in different zones. They're also very important to get that kind of information. Land use per zone or per subzone. So when we hear, say, zone, it can be any kind of scaled geographical entity. But here we have urbanization density, and then number of employees, number of school children, number of schools, and also total number of shops, and also their opening hours and different kinds of information that are associated with all those activities. Okay. Then the second type of information that we need is the microscopic population data. So what do we mean by microscopic population data? These are basically the different aspects or characteristics of all individuals in our study area. So age, gender, household composition, work status, income, number of cars, and etc. So these are the major and the most important characteristics of all those individuals in the study area. Later on, you'll see how age or gender could be different for different scenarios. So you can imagine that age or gender can have an impact on people's behavior and their decisions, what to take, where to go, and how and when to do that activity. In addition to the population data and also the study data, we need some sort of survey data, because we basically, okay, we have a model, but we need to feed that model to be able to predict in the future. So what we have done quite an extensive data collection. It's not anymore an ongoing data collection, but it took us quite some time, over 5 to 6 years, to collect all those data. So we started with different versions of feathers. Version 0, where we started with only 6,000 questionnaires completed, and we ended up with 20,000 queries and questionnaires being filled out by the individuals throughout Flanders. So that's just an example for Flanders. Unfortunately, I'm not aware of that sample size for other places that we actually used feathers for. So here we are talking about observed activity travel diaries. In the beginning, it used to be kind of pen and pencil sort of diary preparation. So we asked people to just write down what kind of activities do they do at what time, from where to where. But later on, we made it more easier for them. So they were actually using some sort of app or some sort of special tool that they could easily click on the input, and then based on the GPS data, all sort of information about the routing was kind of collected automatically. So how the prediction of travel behavior happens actually? By means of feathers, we simulate the following aspects. So which activity is going to happen from where to where, and at what time, how long does it take, with whom are you going to do that activity, and what is the transportation mode that you're going to take. Okay, just to give you an example, I'm going to do some shopping. Where I'm going to, that's a supermarket around the corner. When I'm going to do that, after I come back home, right, from work. For how long? Most probably half an hour. With whom? I'm going to do it alone. And how? Most probably I will just walk. So it was just an example of one simple sample point in our data, how does it basically look like after we simulated by means of feathers a kind of activity at a time for one individual. This is just another example. As you can see, okay, we sleep overnight, we wake up. Most probably this person has to go to Brussels, so he has to wake up very early. Then he stops working somewhere at around 1:32, I don't know why. And then he goes back, oh, okay, it was a lady who has to do some shopping. So she went for shopping, then gym, coming back home, watching TV, and then sleep until the next day. So what does it mean? It means that in our feathers model, for each individual, we have the entire schedule for 124 hours. So from the moment that he or she is sleeping until the next day. For 24 hours, we have all different activities recorded or simulated, and we basically know what kind of individual is doing what, when, and where, right? So it will become more clear when I just show you some examples, so you can see what kind, why is it relevant to have such detailed information. So what kind of policy implication does it have? How we can actually use this to improve our daily activities. The outputs. So the outputs are basically individual activity travel diaries, as I said before. What we can do, we can also get as an output some sort of results for different travel demand management or policy measures and scenarios. I will come back to that later, but just to give you an example, for instance, if you want to promote teleworking, so you assume that 5% or 10% or 15% of your employees can actually stay at home and work at home, right? So the system can basically simulate based on the daily diaries that we collected, what are the chances or what are the distribution, what is basically the distribution of people who tend to telework. On which day of the week do they tend to telework more? So this is just an example, but we'll come back to that later. So what we can have, detailed segmentation in time, space, and also by means of socio-demographics. What does this mean? It means that by means of feathers, we can know what kind of activities for a certain group of people, like youngsters, male, what are they doing in the early morning on a Monday? Maybe this example was not very intuitive, but there are some specific parts of our society that we are more concerned about, like the elderly people. It's very important for us to know what do elderly people do during the weekends. Are they going to go for far distance trips, or are they going to just stay? How the situation looks like. Maybe they are immobilized during the weekend because there is nobody who comes and help them to move around. So those are all different questions. There are hundreds and thousands of different possibilities to check all those different potential outcomes. We can also do some traffic assignment. So basically the output of feathers is a series of origin-destination matrices. And those origin-destination matrices can be different for different times, for different days of the week, for different groups of our society, for different genders, for different age groups, for different types of activities or all types of activities together, for different trip purposes. So we can have those OD matrices as detailed as possible. We can also have some traffic flows. For public transportation, that's maybe less interesting because public transportation, we do not have the opportunity to influence that a lot. So And it's also very difficult to create or alter public transportation. And when I talk about public transportation here, I mean mainly train, because we cannot basically change train infrastructure very easily. But for cars or for buses or for trucks, because they are using the same infrastructure, so it's very easy to also simulate and assign that traffic on our road network to see how vehicle flow looks like. As I said before, there are some specialized models like traffic safety or emission that can be used. So they are different modules apart. Basically, I did my a part of my PhD working on this module. There you can get all those output information from feathers and feed into different models to see if different travel demand management strategies are going to have an impact on emission or traffic safety. Later on, I will come back to this and you will see some examples to better understand what the situation looks like. Okay, here, just talking about outputs. As I said, the first type of output that we can have, there are different types of activity travel statistics. So, here from the below, we have male versus female. So what you can actually observe here is that male in general, as a car driver or motorcyclist, males are more active in this specific type of activities, or let's say that part of our society is more active when we consider them as a car driver. So when the transport mode is driving a car, men are more active than women. We also have this information segmented and divided by different age groups. So as you can see, 18 to 34, 35 to 54, and so on and so forth. Then when it comes to different sort of scenarios that we have. So in this slide, you can see that we have the feathers base here, or the default situation, do nothing situation, the current situation. And then we have teleworking, we have fuel cost scenario, level of service of public transportation improvement, and also the aging of population. What you can see is that, for instance, there are different things to observe in this figure. But as you can see here, there is no impact on the amount of travel. This is basically the billion person kilometers travel. For male above 65, when it comes to teleworking scenario, of course that makes sense, because 65ers do not work. So the teleworking scenario does not influence them, right? Or when you have a look at, for instance, the fuel cost scenario, you will see that almost for all cases, the fuel cost scenario has the biggest impact on travel demand. So meaning that if we increase the fuel cost by a percentage like 5 or 10%, we will have this reduction in usage of car as a driver, right? Because the fuel cost is increased, so you tend not to take your private car. However, the situation is different when it comes to passenger car, because we also have this extra mode to be a car passenger. As you can see here, unlike the previous slide, female appear to be more like a passenger. So they want to accompany other drivers, either they are female or male. But it means that car passengers are predominantly female. And as you can see here, in the case of fuel cost scenario, just unlike the previous one, you see a kind of increase. So what does that mean? Can you just imagine why is it this like this? Yeah, instead of taking 2 cars, they just accompany someone else as a passenger. So it means that our travel demand is increased for whom? For car passengers when you increase fuel prices. So you see that fuel price increase does have an impact on car driver exposure versus car passenger exposure. So this means that increasing fuel does not mean that all types of people or all types of users are going to experience lower exposure, right? So these are just a few things that you can actually get from this figure. Another possibility, so from now on I just come up with some very specific questions that might not be very intuitive for some and might not be also very generic, but I'm just showcasing how specific you can be in answering different types of questions when you use this activity-based model. So here the question is that we basically want to go from this location to this location. If we take the train, it goes like this. If we take the car, it goes like this. But what if, due to any kind of reason, a kind of work zone situation or reconstructing the road, there's going to be a kind of delay by 20 minutes. So how does it actually impact people's behavior? Ui, that was too fast. So this is the composition of different transport modes at the current situation. So as you can see, 51% are taking the train because they don't want to get stuck in the Antwerp suburb. And just for your information, Antwerp and Brussels, they are very small cities, but they have the highest or the most intense traffic jams in the entire Europe. So that's, I mean, proportionally speaking, okay, they cannot be compared to Paris, the total amount, but according to the size of the cities, they have the most intense traffic jams in Europe. So, okay, 20 minutes extra travel time. What would you actually expect? You would expect a kind of increase in your train demand. Maybe also other transport modes. But the question is that, okay, this is the trend that you would expect. 20 minutes extra for traveling with the car, with your private car. But the question is that where do that decrease, or where do that kind of extra demand or the reduced demand actually goes to? Does it go to only train or public transportation? Or do people actually take their bikes? As you can see in this case, there is a 2% increase in bike usage, meaning that the people who think that, okay, it's still doable to cycle from that origin to that city, they can still make it by bike. What is important from the planning perspective is that where does this modal shift occur? So does it occur only towards trains or towards buses, or will there be actually any kind of impact? Because if that delay is less, like 5 minutes, the situation is totally different. So how is it important? Just to give you an example. This type of delay can be caused by a kind of road reconstruction. And normally road reconstruction in Belgium, it takes ages. So if they want to rebuild a stretch of, I don't know, 20, 25 kilometers, it most probably takes more than 3 months or 4 months to cover that. So in advance, you know that there will be that kind of delay, right? And you would expect that kind of modal shift towards train. So what you can do, you can basically alter your train schedule, add more trains, or just reduce the gap between the scheduled trains to accommodate this. So this is just an example of how we can basically improve our performance, our network performance, and also make it more sustainable and viable. Another example is the effect of 5% teleworking. So as you can see, changes in travel demand looks like this. So for cars, there will be 1.5% reduction. For car passengers, it's less, just 0.2. Public transportation sees actually the most or the greatest reduction by almost 2%. And then slow mode or active mode by 1%. Right. So these are some sort of, I would say, macroscopic changes. But if you look at different days of the week, you can see that the most and the greatest reduction is on Wednesdays. This is actually true because in Belgium and in Flanders, on Wednesdays, schools are half-day open. So schools are only open until 12. Everybody goes home. Which means that it makes basically Wednesdays a more attractive day for parents to stay at home. And that's why you see the most decrease for a Wednesday, right? So you can see that one specific travel demand management scenario, which is teleworking, and it's only 5%, right? It can have different impacts on different days of the week, not even on different transport modes, but also on different days of the week, right? What does the traffic intensity on a Flemish road network evolve over time, 24 hours on a Monday? So, before I start showing this video, just to refresh you, I just want to ask you to just have a look at this tiny little part of our road network, right? This one. All around this point, this is Netherlands, but this is Belgium or Flanders. It's ironic, yeah? So actually, this part becomes a kind of touristic place that many people go and visit. And what is funny about it is that for that specific area, which is very little, just less than 1 kilometer or 2 kilometers, this house has a Belgian plate number, if you wish, and the house besides it is Dutch. And then the other one is again Belgian. So that's the kind of situation that you can see to just add more complexity to the already complicated situations in Belgium. What is this part? This is basically a kind of German-speaking part of Belgium, but this part is kind of isolated, but this still belongs to Flanders. Thankfully, for feathers, we managed to get all those information also for Brussels. This is Brussels. But I remember from my own PhD, all those maps that I used, there was a kind of white hole here. So once in TRB, I got this question that, oh, I didn't know that there is a big lake in the middle of Belgium. And I said, I'm sorry, where are you referring to? Okay, yeah, here there is a big lake, it seems. Oh, I'm sorry, but this is not a big lake, it's Brussels. But we basically don't have access to crash data in Brussels. And that's why everything just ends here. This was just to give you a kind of idea how the situation looks like. So it's very difficult to get information and data when it comes to different authorities. We can get some transportation related information, but no crash data. Anyway. So this is just the evolution of transportation. Okay. As civil engineers, most of the times we use average annual daily traffic to be our traffic flow measure, right? But later on you will see how important is it to have more detailed kind of exposure, and I would call it a more dynamic sort of exposure, and not a static one which goes just as one measure for one entire day. Okay, another question that might come into your mind. So, on a Monday, 65 plussers are people on pension, huh? Of course, it should be 67 plussers, but okay. What do they actually do on a Monday? Or basically, how mobile or how active they are. So as you can see, the pink ones are the subzones where they are most active, while the purple ones are when they are less active. So what can we actually learn from this figure? For instance, if you look at those purple ones, the majority of them are at the borders. So we already know, as a matter of fact, that our public transportation at borders are not so good. So it could actually explain why those people are less mobile and why there are less people actually active in those areas. So this can give road authorities a kind of warning message that, okay, where do you see less activities, although there are, if you look at the population distribution, you see that, oh, there are still lots of 65 plussers living in those zones, but why they are not that much active? So there could be something wrong with the transportation infrastructure, right? Do we need to change this, or? Okay. Another example. So on this specific piece of road, we would like to see at a very specific time of the day, of a specific day of the week, who are actually those people? Where are they coming from? And where are they going to? So it is possible to see this. So as you can see, the order is not correspondent to our flag. It's more, it's different, but okay. So the yellow one is basically the place that we're interested in, and these red ones are the kind of route or the path that those people are coming from and are taking, actually. And the black one are the kind of roads that they basically take to go to their final destination. So why this could be relevant? If you just do some sort of exercise and see, oh, there are lots of people who are going, not in this case, from this area, and they have to come here and go there because there is a lack of good infrastructure or connection between this area and this area. So they have to come down and then go up. What we can actually do, if that happens, is to check whether we can actually improve the situation somewhere here, so we can make a better link between those two areas, right? As I said before, in the kind of simulation process, we can incorporate different traffic demand management scenarios, like teleworking or traffic safety. And then here we can, increase of fuel cost. So if we increase fuel cost by 20%, what would be the impact on travel demand? So you can see it here. You basically expect less car traffic because fuel is more expensive now. And then there will be more people tending to share cars with others. So there will be more car passengers. There will be more people who are inclined to use public transportation or to walk or bike for shorter distances. So this is the situation, how it looks like when we actually impose 20% increase in fuel cost. Then what would be actually what do you expect to be the impact on traffic safety? So basically there are less car trips, so we expect less car accidents, right? But as you can see here, so this represents car fatal serious injury. This is car slight injury, and then car slow mode fatal and serious injury, and car slow mode slight injury. So as you can see, as a result of such a scenario, we expect more travel demand for those active mode transportations, which means that we could expect some more crashes for that specific part of our travel demand. So although it is more beneficial from the economical point of view, it's better for people's health because there will be less crashes involving cars, right? But we have to also take it into account that the problem could be migrated elsewhere. So that's what you have to actually take into account. Here is why, when I talked about average annual daily traffic or dynamic exposure, how it can be actually important. So what could be the effect if we have dynamic exposure, meaning that we have it for every hour of the day, or we have a static, which means that we just have one number or one value for that. So as you can see, the upper map shows the exposure to pollutants using a static exposure, and here using dynamic exposure. In this map, you see the differences. What is important to notice is that if you look at these areas, which basically represent the most biggest cities in Flanders, there will be a kind of underestimation. So in these areas, when we are talking about big cities, the situation is actually worse in reality. But if we just take the static exposure, this is what we are going to miss. And for other areas, because you can see the gray or blue kind of zones, we have a kind of overestimation. So the situation is not that bad as we would expect. So as you can see, here is darker than here, meaning that the static exposure gives us a kind of worse situation when we take a static exposure. What is important perhaps for us is that if we take this and not this, we are going to underestimate our exposure to pollutants in big cities, where we have the most problem actually. So this is only becomes possible when you have the opportunity to have that exposure dynamically assigned to your network. The parking model is also another model which uses the outputs of feathers. So what is the impact of free parking in Antwerp on a Saturday? Normally, On Saturdays, people tend to go out for shopping purposes, also recreational purposes. So this is the city center of Antwerp, the biggest city in Flanders. But this is the situation actually. These numbers, or this legend actually expresses the amount of parking spaces that are available to be occupied. So as you can see, in the middle of the city, it's almost 80 to 100% occupied. But in the borders, you can still find some places that there are not much parking there. So if you compare it with the free parking scenario, which means that we are not going to ask you for anything, you can just park wherever you want. The thing is that except of very few locations, the situation remains very similar for the very city center, right? So as you can see, there are many people who tend to go there regardless of the amount of money that they have to pay to park, right? But the difference actually occurs more to the borders and when you get a little bit farther from your city center. From the policy point of view, then what would actually you do? Are you going to make Saturdays free parking in Antwerp or not? If yes, what are the consequences? You basically lose quite some money. But putting that aside, so what are the environmental impacts? As you can see, there will be more parkings being occupied here in this area, which means that there are more cars coming to the city, which means that there will be the possibility of traffic jams when you are approaching the city or you are leaving the city. That's one thing. However, on a more economical point of view, it means that you attract more people. So the small businesses or shops within the city center would be busier and would be actually attracting more customers, right? This is yet another example of how feathers can be actually used to see if such a scenario is going to be implemented, what are the potential impacts, and it just let the decision makers make their decision to whether to go for a free parking Saturday or just stick to the situation before, or if you see that there are too much traffic here, they even may increase it. So it is possible to check out the impacts and the consequences of different sorts of scenarios for one specific task. By this, I come to the end of this presentation. The intention was just to show how an activity-based model can actually be used to enable decision makers and policy makers and road authorities, help them create a more sustainable and a better transportation network. I would like to thank you for your attention, and if there are any questions, please shoot. Yes. Thanks. Yes.
When we look at the car injuries, the bold in red, it's the amount that we do into consideration, 4% for the free.
Mm-hmm.
But my question is, how precise is the calculation? Because .5 or .8
Yeah, definitely. This is actually because this is just an example for the average of 1 week, right? As I said, Feathers is still a kind of simulation platform, so it just simulates. It could be that one simulation could be slightly different than the other. There has been a paper published for actually the minimum required or the optimum required number of runs, which turned out to be for many of these scenarios to be something around 160 runs of simulation for each scenario. So only after you run it for 160 times, then you get the average, and that's a kind of more robust result. But just to come back on that, although the numbers, so the magnitude of the changes may be also important to see, okay, will there be 1% or 5%? That's a huge difference. But what is more important for us is to also have a kind of qualitative or relative comparison between the results, right? So this is important to know that if we increase fuel cost, regardless of the fact that if it's going to be 4% or 5%, of course that's something that are predictions, because crashes are random and rare events, so you don't basically know if there will be indeed 4 or 4.5 or 5% reduction in crashes. But what is important for us is to just know that what are the reverse impacts. Like there will be a positive impact when it comes to car-involved crashes, but we have to also focus on that part, which means that we should be more aware of the reverse or the adverse impacts or consequences of such a scenario. Yeah, so the magnitude might be different, but the trend or the direction, yeah. Yes.
You mentioned that people feel a sort of survey in an app,
Yes.
right? And my question is, in diary, people feel is during the day or at the end of the day?
In the beginning, when it was paper and pencil, it was very difficult that they just had to fill it in every now and then. So they did it at the end of the day. Okay. Yes. But when it was more advanced, so we had some sort of notebook that records their GPS location, and also it gave them, it was more intuitive to be used and more friendly, so they could just choose from different activities. The time was recorded already there automatically, so they didn't actually need to write down the time and the path. They just need to take the tick for transport mode and with whom they are actually going or where to go. So everything, most of the things were collected automatically, and then it was possible to do it in real time. Yeah.
I listened to it because with one time result at the end of the day, people tend to forget.
Yes. Yeah, that's true. That's true. But as I mentioned, we started with 6,000, and we ended up with 20,000. So the more we get information, we just had a kind of richer sort of database. But I can tell that the majority of the input data that is used to learn the model use that kind of more precise data collection system. Yeah. It's because the thing is that the available amount of data that, or the diversity of the data that we require to have such detailed prediction cannot be very easily collected by that sort of sources. So we had to really rely on individual diaries and to see exactly what kind of people inclined to do what kind of activities and where and with what. So the input data is quite should be quite detailed to be able to accommodate this model. Thank you.
Thanks so much, Ali. So now we are finishing, and this is our the end of our first seminar of transport terrestre. I would like to invite you to stay because I'd like to join all of us to take a photo. Before this, I'd like to remember that tomorrow up to Friday we have the short course with Professor Ali.